You've just contracted a parasite. But this isn't just a normal parasite. This is Pseudopulex, a parasite that existed 127 million years ago. And unfortunately for you, this guy is not friendly. Prehistoric parasites are designed for a world completely different than modern day, often a world filled with much larger and more violent creatures. But if prehistoric parasites suddenly came back today, would we actually be able to handle them? When people hear the words prehistoric bug, they immediately assume everything back then was the size of a golden retriever. And it makes sense why people think this. We know that certain ancient insects, like the Meganeura dragonfly, had wingspans of over 2 feet. So only logically, if a dinosaur is 50 times the size of a human, its fleas and ticks must have been the size of house cats, right? Actually, no. And not just, oh, they were only the size of rats. They were fundamentally still just bugs. The Jurassic flea, for example, only grew to about the size of a modern cockroach.
And honestly, that's infinitely worse.
If a flea was the size of a dog, you could just lock your doors. You could see it coming down the street and you could defend yourself against it. It would just be another medium-sized predator. But a cockroach-sized parasite? That's small enough to slip under your baseboards. It can hide in your closet, crawl through your air vents, and completely infest your home without you ever noticing until it's too late. But these things aren't looking for dropped breadcrumbs in your kitchen. They're strictly hunting for blood. And their mouth parts had to physically saw right through dinosaur scales. So what actually happens when a parasite built for a dinosaur tries to feed on something from the modern day? Let's imagine a normal golden retriever is playing in the backyard, and it picks up a Pseudopulex, the same giant flea from the Jurassic period. Sorry buddy, you're just the best example for this. With a modern flea, the bite is basically just a microscopic needle. The flea slips between the hairs, pokes a tiny hole, drinks a fraction of a drop of blood, and leaves behind an itchy bump. It's annoying, but it's completely harmless to the dog's actual physical structure. But the Pseudopulex doesn't have a microscopic needle. It has jaws that look like this. Remember, this creature had to penetrate the hide of feathered dinosaurs and reptiles. Its jaws were built to drill straight through their scales. So when this cockroach-sized nightmare lands on a golden retriever, it's not going to make our little puppy super itchy. When it bites down, those serrated jaws slice completely through the dog's thin skin, tearing into the muscle underneath just to anchor itself in place. That's just straight up severe physical trauma, which is genuinely not what you want from a bug bite. And because the flea is so large, the amount of blood it needs to consume is completely disproportionate to what a modern pet can handle. A severe infestation of modern fleas can make a dog slightly anemic over a few months, but just a handful of these Jurassic fleas would drain a dog completely dry in a matter of hours. Because they're so ridiculously over-equipped for a modern animal, just the basic act of them eating is a fatal injury. But honestly, getting sawed open by a giant flea isn't even the worst way these things could kill you. In 2017, scientists discovered a piece of amber containing a perfectly preserved tick. They named it Dinocruton draculae, which literally translates to Dracula's terrible tick. And honestly, whoever named that deserves a raise, because that's incredibly accurate. The tick was found tangled in the feather of a dinosaur, and it was engorged with ancient blood. Now, if one of these Dracula ticks were to bite a modern human, the physical bite would obviously be painful, but ticks aren't usually dangerous because they suck a little bit of blood from you. Ticks are notorious for carrying diseases. Today, a standard deer tick can give you Lyme disease, which can cause lifelong neurological and joint problems if left untreated. But our modern immune systems and our modern antibiotics at least know what Lyme disease is. Our bodies have been evolving alongside these modern pathogens for millions of years. Our bodies actually know how to fight them. If a Dracula tick bites you, it's injecting bacteria, viruses, and bloodborne pathogens from 100 million years ago directly into your veins. Your immune system has absolutely zero evolutionary memory of these diseases. Your white blood cells wouldn't even recognize the ancient pathogens as a threat. They'd basically just look at this 100 million year old virus and go, is he with you guys? Until it already completely multiplied and overwhelmed your organs. We wouldn't have vaccines. Our broad spectrum antibiotics might be completely useless against bacteria that evolved under entirely different conditions. A single bite could easily be the spark for an unstoppable prehistoric plague.
So this means we're all completely doomed, right?
Well, before we panic, these ancient bugs actually have an even worse problem to deal with first. We're assuming that a dinosaur tick would actually want to bite us, and realistically, they probably wouldn't even recognize us as food. Parasites are incredibly specialized creatures. They don't just drink any red liquid they find. They're chemically tuned to hunt specific hosts based on body heat, carbon dioxide emissions, and the specific proteins found in the host's blood. Dinosaurs were vastly different from modern mammals. Their blood had different chemical makeups, different cell structures, and different core temperatures. If a Dracula tick landed on a human arm, it might just sit there, completely confused. The temperature of our skin is wrong. The smell of our sweat is wrong. To a prehistoric parasite, a human barely even registers as food. We basically just register as a weird cold rock. And even if the tick was absolutely starving and decided to take a bite anyway, human blood might literally be toxic to it. The proteins and immune responses in mammalian blood are entirely different from those in ancient reptiles. So, ironically, the most likely outcome of bringing a Jurassic flea into the modern world is that it just wanders around your living room for a few days and then quietly starves to death because our biology is just completely useless to it. But this wrong host rule really only saves us from the external bugs. What happens when we look at the things living inside the body? While external parasites like ticks and fleas have to worry about biting through skin, internal parasites just bypass the armor entirely. They live directly in the digestive tracts of their hosts. And we know for an absolute fact that dinosaurs were heavily infected with them. Paleontologists have found fossilized dinosaur feces, called coprolites, that are absolutely packed with the eggs of ancient tapeworms and nematodes. And the problem with internal parasites is that their size scales directly with the size of the animal they're living inside. A modern tapeworm living in a human can grow up to 20 feet long, but a tapeworm living inside the intestines of a 30-foot, 10-ton dinosaur, that parasite would have to be huge just to survive. Tapeworms don't have mouths or digestive tracts of their own. They just sit in the host's intestines and absorb the nutrients. Or really, steal the nutrients. A dinosaur consumed hundreds of pounds of vegetation or meat every single day. So what happens if the eggs of a dinosaur-sized tapeworm contaminate modern soil, and a modern animal, like a cow, accidentally eats them? The tapeworm hatches, attaches to the cow's intestines, and just starts growing. It expects to be absorbing hundreds of pounds of nutrients, but a modern cow simply doesn't eat enough food to sustain a parasite built for a dinosaur. The parasite would aggressively drain every single nutrient the cow consumed. The cow would eat constantly, but it would rapidly starve from the inside out, completely drained dry in a matter of days. And then, the tapeworm would just die of starvation anyway, because the modern world simply doesn't produce enough calories to keep it alive. But calories aren't the only thing the modern world is missing. There's a very specific reason why we don't have giant insects crawling around today, and it has nothing to do with predators. It all comes down to the air we breathe. Insects don't have lungs. They breathe through tiny holes in their exoskeletons, and the oxygen basically just soaks straight into their bodies. And because of this, an insect can only get as big as the oxygen levels allow. During the Carboniferous and Permian periods, the Earth's atmosphere had significantly higher oxygen levels than it does today. This is what allowed insects to grow to horrifying sizes. If you were to take a prehistoric parasite and drop it into a modern city, it wouldn't go on a killing spree. It would immediately start suffocating. The modern atmosphere only contains about 21% oxygen. To an insect built for an ancient environment, breathing our air would essentially be impossible. Their massive bodies wouldn't be able to pull in enough oxygen to power their muscles. They'd become incredibly sluggish, barely able to drag themselves across the floor, before eventually passing out and dying from hypoxia. Our modern air is literally toxic to them.
But not all prehistoric parasites relied on high oxygen levels.
Some of them didn't even need to breathe at all. If you're familiar with the cordyceps fungus, you already know it's one of the most disturbing things in nature. It infects an insect, physically takes over its nervous system, forces the bug to climb to a high branch, and then kills it, erupting a stalk out of the bug's head to drop spores onto the colony below. Yeah, it's just as gross as it sounds. Today, this fungus is highly specialized. There are thousands of different species of cordyceps, and almost every single one of them can only infect one specific type of insect. The fungus that infects bullet ants cannot infect a spider, but it took millions of years of evolution to get that specific. Scientists have found fossilized evidence of a mind-controlled fungi dating back nearly 50 million years. And the terrifying thing about these ancient ancestors is that they likely hadn't specialized yet. Instead of being locked to just one species of ant, an ancient mind control fungus might have been a generalist. It could potentially infect a massive variety of insects. If an unspecialized cordyceps was released today, it could easily jump across species barriers. It could infect modern ants, beetles, and most importantly, bees. This is where a prehistoric parasite actually causes a global catastrophe. If an ancient zombie fungus began infecting modern pollinators and our modern insects had no evolutionary defense against it, our entire agricultural system would collapse. The fungus would hijack the bees, force them to spread the spores to every hive they interacted with, and wipe out the insects responsible for pollinating the crops that feed the entire planet. This time, the parasite wouldn't even need to bite us. It would just completely dismantle the foundation of our food chain. But this always brings up the most famous sci-fi question of all. We've all seen the movies and played the games where a mutated fungus jumps to humans and turns people into mindless zombies. If an ancient, highly aggressive fungus was suddenly reintroduced to the world, could it actually take over a human brain? The short answer is absolutely not. And the reason why is actually one of the greatest evolutionary advantages mammals have ever developed. We're incredibly hot. And no, I don't mean that in a flattering way. And although I'm sure all of my viewers of the Beyond the Green channel are absolutely beautiful, what I mean is our literal physical body temperature. Fungi are fragile. The vast majority of fungal species on Earth physically cannot survive in temperatures higher than 85 degrees Fahrenheit. The proteins in their cells literally begin to cook and break down. The human body maintains a constant internal temperature of 98.6 degrees. To a prehistoric zombie fungus, entering the human bloodstream means they'd literally just cook alive. We're simply way too hot for them to survive, let alone hijack our central nervous system. So we're completely safe from ancient mind control. But just because we're too hot for fungi doesn't mean we're safe from everything. Because while fungi hate the heat, ancient skin-burrowing mites don't care about your body temperature at all. They'd happily just eat you alive. So, on land, we're mostly protected by our body heat, our lack of dinosaur blood, and our low oxygen atmosphere. But what about the ocean? The oxygen limit that protects us from giant insects on land completely stops mattering the second you go underwater. The ocean is incredibly stable. The water down there hasn't really changed the way the air up here has. This means that if you brought a prehistoric marine parasite into the modern ocean, it wouldn't suffocate. It would survive perfectly fine. Take the ancient ancestors of the lamprey. Today, lampreys are essentially swimming leeches. They latch onto fish with a suction cup mouthful of teeth, scrape away the scales, and drink the blood. Hundreds of millions of years ago in the Paleozoic era, the oceans were filled with massive fish called placoderms. To feed on these swimming tanks, ancient marine parasites had to evolve ridiculously powerful mouths just to get through the bone. But modern fish don't have heavy bone armor. Evolution traded heavy armor for speed and flexibility. Ancient fish had literal bone armor. A modern tuna has being slightly slippery. So if you introduce an ancient parasite into an ocean full of modern fish, the modern fish are basically defenseless. The ancient parasite would latch onto a modern tuna or a shark, and those overpowered jaws would instantly core completely through the fish's side, killing it almost immediately. Modern marine life just isn't built to survive something like that. But surely, the largest animals in the modern ocean would be safe, right? Let's look at how this would actually play out in the deep ocean. The megalodon was the largest predatory shark to ever exist. And just like modern sharks, it undoubtedly had highly specialized parasites. So what happens if a tapeworm, specifically evolved to live inside the intestines of a 50-foot megalodon, manages to infect a modern blue whale? Well, let's assume that it even can infect the blue whale. You might think that because the megalodon was a prehistoric monster, its parasites would be equally devastating. The tapeworm would grow to massive sizes, draining the whale's nutrients and causing severe internal damage. But the reality is, the blue whale wouldn't even care. Actually, it probably wouldn't even notice. because the scale of the blue whale is simply too massive for almost anything to actually threaten it. Yes, the megalodon was huge, but the blue whale is nearly double its length and can weigh up to 150 tons. It's the single largest creature to ever exist in the history of the Earth. If a megalodon tapeworm got into a blue whale, it would absolutely thrive. The whale consumes literal tons of krill every single day, providing an endless buffet for the parasite. The tapeworm would grow to its absolute maximum prehistoric size. But it wouldn't kill the whale. The whale is eating so much food and has so much excess fat that losing a little bit to a tapeworm just doesn't matter. It's basically like you losing a single penny out of your bank account every day. The parasite is huge, but the host is just so much bigger that the threat completely disappears. Size alone is one of the greatest defenses in nature. But what happens to the rest of the ecosystem? If prehistoric parasites were dropped into the modern world, this wouldn't be some horror movie where monsters hunt us down. Look at what happened when humans introduced cane toads to Australia. The toads had no natural predators. The local wildlife didn't know how to fight them, and the toad population absolutely exploded, devastating the ecosystem. Now imagine doing that, but across millions of years of evolutionary time. If an ancient parasite actually found a modern host it could feed on, it would have zero natural predators. Modern birds wouldn't know to eat them. Modern grooming behaviours might not be effective against the specific way they attach. They'd breed completely unchecked. They'd swarm local wildlife, draining deer, livestock, and small animals at an alarming rate. They'd basically just eat everything in sight. Eventually, the environment would course correct. The parasites would eat themselves out of house and home, depleting their food sources and dying off from the oxygen limits and climate mismatches. But the initial shockwave of their population boom could cause irreversible damage to modern ecosystems before they finally went extinct again. But this assumes modern animals are just helpless victims waiting to be eaten, and that's a massive underestimation in modern biology. There is a common misconception that prehistoric animals were the absolute strongest things to ever live, and that modern animals are just smaller, weaker, downgraded versions of them. This is completely false. Modern animals have spent the last 65 million years constantly fighting off parasites, and we have developed defenses that dinosaurs couldn't even dream of. Think about the physical structure of a Stegosaurus or an Ankylosaurus. They were basically just massive walking tanks. If a giant tick latched onto a Stegosaurus's back, the dinosaur literally couldn't do anything about it. It didn't have the flexibility to reach its own spine. It basically just had to accept its fate and go, well, I guess this is my life now. Now look at modern mammals. We're incredibly flexible. We have fast twitch muscles, sensitive skin that instantly detects when a bug lands on us, and highly coordinated limbs. If a bug lands on a monkey, the monkey just reaches over and rips it off. Problem solved. Plus, mammals actually evolved social behaviours just to deal with this. Baboons, chimps, and even birds spend hours every single day grooming each other, meticulously picking through fur and feathers to remove ticks and fleas. Prehistoric parasites evolved to feed on slow-reacting reptiles. If they tried to attach to a modern pack of wolves, the wolves would just bite them off and eat them. We're actually significantly harder targets to stay attached to than a dinosaur ever was. We're hyper-aware and we fight back. And no animal fights back harder than humans. If a swarm of giant Jurassic fleas or Dracula ticks actually managed to adapt to the modern world and started attacking people, the initial outbreak would obviously be terrifying. Seeing a cockroach-sized flea jump onto your dog is pure nightmare fuel. But humanity wouldn't lose this war. In fact, we'd win it incredibly fast. Because while these ancient bugs have giant jaws and tough exoskeletons, their brains work exactly the same way as modern bugs. And humans have spent the last 100 years getting really good at inventing bug spray. We have DEET, we have ivermectin, we have industrial grade pesticides that can wipe out entire generations of insects in a single afternoon. A giant prehistoric tick might be immune to a dinosaur's immune system, but it's absolutely not immune to a direct blast of Raid bug spray. The chemicals would instantly overstimulate its ancient neurons, causing it to paralyze and die in seconds. If these things become a threat, we could literally just drop crop dusters full of modern insecticides all over the affected areas. We'd put anti-parasitic medication in livestock feed. The ancient bugs wouldn't stand a chance. They might have serrated jaws, but that means absolutely nothing against, well, a guy in a hazmat suit with a spray can. So, if we can easily defeat the giant monsters of the past, what should we actually be afraid of? It's easy to look at a fossil of a giant prehistoric bug and think that the past was a much more dangerous place. We assume that because things were bigger, they were deadlier. But evolution is all about efficiency, and over millions of years, parasites realized that being huge is actually a massive disadvantage. If you're a giant flea, you require a massive amount of blood, you're easy to see, and you're easy to kill. The scariest parasites are actually the ones that just got smaller and vastly more efficient. The giant Dracula tick from 100 million years ago is terrifying, sure, but the modern mosquito is so small you barely feel it land, and it carries malaria that kills hundreds of thousands of people every single year. And we definitely don't need to stress about a giant dinosaur tapeworm when we have microscopic brain-eating amoebas that slip through the water completely undetected. Evolution just made them invisible. The real deadliest parasites to ever exist aren't buried in fossilized amber. They're all the ones left today. But anyways, I hope you guys enjoyed this hypothetical style video, and I really appreciate all you guys who are supporting me in the comments. Make sure to finish your 19 overdue assignments though. And if you want to see our video about a modern day animal, you can check it out here.